I'm presenting the current station on behalf of the blue team, who consists of Justin Cartwright, Khan Nguyen, and myself. So a quick outline of what's going to be discussed. I'm going to go over the current system background, and then to present the new data, you kind of have to know the old data. So I'm going to recap previous experiments and go over the steady state operating curve, the step response, the FOPDT model, and then I'm going to get into the frequency response with the Bode charts, the frequency model, and then I'm going to compare the results of the frequency response with the step response. And then I'm going to have a conclusion. So a little theory and background. Our system, we put in an input, which is a percentage of power, goes into the motor generated system, and an output in amps is our output. This is the schematic for our system. However, due to some complications with the motor and the operations of the system, it kind of failed. So we changed from voltage system to current system. And we still have somewhat lingering complications with our system, but we're doing the best we can with it. Here's some photos of the current system, and there's the motor that failed us somewhat, and the lights that we're providing current to. So here's a steady state operating curve that falls within the range of 3 to 4 amps. You can see that it reaches steady state about 30 seconds. The input is the blue line, and the output, which is in amps, is the red line. Here's the steady state operating curve for the group. In this graph, it shows that there's a huge gap right here. This is due to the amount of output that we get based on the input that we put in. It was very difficult to fall within the 2 to 3 amp range, higher than 2.5 amps. And it was also very difficult to fall below 3.5 amps. With the input percentages that we tested. So that causes that huge gap right there in the graph. Here's an example step up. It is at 53% with a 20% step. The issue that I faced with this was trying to get between the 3 to 4 amp range again, and we get this little dip here in the step, which causes some somewhat minor but seemingly noticeable changes to data, and it shows in the inconsistencies in the graphs that will be presented further on. You can see that the gain was 0.13 seconds per percent. The step was, like I said, 20%. And due to the uniqueness of the graph, I had to split up my measurements into 3 different graphs, and I zoomed in on certain locations, like to find the dead time. I zoomed in within the 4 to 7 second range so I could accurately measure this and plot it. On this next one, I had to zoom out a little bit to do the 63.2% times my delta C to get my time constant, which was extremely large, of 10.5 seconds. This is my FOPDT of my unit step up, and you can see that this graph shows that it doesn't really follow my actual experimental output, and I think it might be due to the fact that there is this dip right here. And that kind of threw everything off just a little bit. In the unit step down, the data came across much easier and wasn't as unique as the step up. What I had to do is I had to change my unit step down to 85%, which is a huge jump from the 53% I was originally at. And you can see that this gain is a lot smaller than the previous gain of the unit step up, which is also showing that the data is somewhat inconsistent. The dead time stayed pretty much the same at 0.11 seconds. However, the time constant is significantly less than the 10.5 seconds that it took with the step up. Here's the FOPDT of the unit step down. It follows the model very, very well, unlike the step up. Here's the gain results of the unit steps. This is of the unit step as the group. This once again demonstrates that the step up is the one that's the data is somewhat skewed. The dead time was pretty consistent across the board. We had one that was in the middle down, was a little bit different. The time constant was all right around the same amount except for the step up again, which was a whopping 10.5 seconds. So here's the unit step results that we had gotten to. The fit2 was used for all the unit steps. The equation that we used for fit2 was the one given, which was the c times the dead time plus the time constant. The FOPDT model was used to do a model of our experiment, and the side-by-side comparisons were shown so that you had an idea of where each lower, middle, and upper compared with one another. That leads into the frequency, and this is a sine response, once again in the 3 to 4 amp zone, and it breaks it down to where you can measure each one of your values that you need to collect. So once you get all that, you create your Bode plot. This is the Bode plot with the amplitude versus frequency, where we found a gain of 0.063, a 1 over KCU of 0.034, and the order was 0.05. Here's with the phase angle versus the frequency, and it crossed negative 180 at about 6.8 cycles time, so the FU was 6.8. This is the model of the amplitude versus frequency, which is somewhat similar. You can see it kind of dips a little bit more right here, but it's still somewhat similar to the experimental data that was collected. The phase angle, it started off somewhat different, but down around the minus 180 range, it is still very, very close, so it seems like it was a pretty good representation of the data. So here's the comparison of the step and the sine results. This is for the gain. You can see the data is somewhat close, except for the step response for the upper. So that's still one of the things that's been haunting this entire experiment. The dead time, they all remain somewhat similar, but the time constant, once again, is much greater for the range for the step and sine. Even in the frequency experiment, it was greater for the upper range. So here's a model of the orders of all three groups, which span from 1 to 4 amps. The order is somewhat consistent across the board, as well as the FU, which is the cycles per second. They are somewhat significant, or somewhat close. But for the one over the KCU, the mid-range was the one that was slightly off compared to the lower range and the upper range. So to conclude, looking forward, investigation definitely needs to be done on the 3 to 4 amp range, because it's very different in comparison with all the other ranges. I'm not sure exactly what it could be yet, but it's definitely something to look into. All experiments conducted were in between the 1 to 4 amps, an output of 1 to 4 amps. So in this experiment, we showed the comparison of the gain between the sine and the step, the dead time, and the time constant, which the only one that was somewhat inconsistent was the upper range for the 3 to 4 amp zone. That's all.